All right, this is my little frog to tell me that it's time to start again. Part 3. We're going to do the third installment of the mole ratios. Here's where we put it all together. Okay, so working off of the same handout, example 3, we're going to do 3 steps. Now, this is sort of like a mole ratio sandwich, where the meat of the sandwich is the mole ratio using the coefficients. And the bread is the grams to moles and moles to grams steps, which include the formula mass. So let's try it. Take a look at number 9. Number 9, we're starting with 4.55 grams of aluminum chloride. Okay, so if we find that in our balanced equation, here it is, a coefficient of 1. And we want to know how much potassium is needed. Well, potassium is the element K. Oh, it has a coefficient of 3. So it's a 1 to 3 mole ratio. We can't do the mole ratio step right away. We have to first change from grams to moles of the starting material. All right, so let's go to it. Start with what's given in the problem. Grams of aluminum chloride, AlCl3. Oh, by the way, you're welcome for the balanced equation. Control question mark. So what do we do here? Oh, right. Grams to moles. That's our first step. I better total this up. I don't know what aluminum is. Do you? I love my periodic table app. It's the best thing ever. 26.98. Well, I'm going to call that 27. So aluminum has an atomic mass of 27. And there's only one of them in the chemical formula. Chlorine, I think I know it by heart. Yep, 35.5. There's 3 of them. 3 times 35.5. And shazam, that is the mass of 1 mole of aluminum chloride. So we're going to use that first. So far, this should look like almost every other mole problem we've ever done. All right, 133.5 grams of AlCl3 for every 1 mole. We haven't used coefficients yet. Those don't come into the mole ratio step. Okay, so far so good. Nothing new, just changed from grams to moles of aluminum chloride. Now we go to the mole ratio. That's the meat of our sandwich. Well, what we're looking for goes on top. We know we want to know, we are looking for potassium. The coefficient for potassium is 3. So let's put 3 moles of K in the numerator. The denominator is going to cancel out the aluminum chloride. And it has a coefficient 1. So we have 1 mole of AlCl3. Just be careful with your units to use the same thing. All right, so the mole ratio step has effectively changed from moles of the starting material to moles of what we're looking for. The final step in our mole ratio sandwich is another grams to moles conversion. Here we want to take moles of potassium and change to grams of potassium. Potassium, oh right. We already looked that one up, didn't we? No, we didn't. Oh heck. Potassium, there you are, alkali metal, 39.1. It's easy. There's only 1 K in the chemical formula. There's no adding. We're just going to put it right in there. 39.1 grams of K. I love it when it's that easy. For every 1 mole of K. All right, so shift return, and there you have it. Grams of potassium, all of our units canceled out. Only thing left to do is round to the correct significant digits. So our final answer here, 3 significant digits, because 4.55 has 3. Oh, it's going to be 3.997, so we have to round up. It turns out to be 4.00. I hate it when it comes out like that because everyone gets confused. But because of the way that number works out, we have to round it all the way up to 4.00. That number has 3 significant digits. So just a quick review. Start with the number given in the problem. First step, we changed from grams to moles of the aluminum chloride. So we totaled up all the atomic masses of the elements in the compound. And that's the mass of 1 mole. Now that we've done that, we get to our mole ratio step, which is the middle step of all these 3-step problems. Here's where we use the coefficients from the balanced equation. Here and only here. So we have 3 moles of K for every 1 mole of AlCl3. So that's represented in the mole ratio. The final step, moles of potassium to grams of potassium. So here we're using the moles of potassium, which is 39.1 grams. I'm sorry, we're using the molar mass of potassium. And that's it. So really, this is not anything new. We're using the mole conversions and the mole ratio all together. Let's try another one. Number 10. Oh, there's that excess word again. Don't freak out. Just stay calm. Excess means that reactant does not factor into the equation. All you got to think about is what's given in the problem and what you're looking for. So in this case, we're given 650 grams of aluminum metal. We want to know how many grams of aluminum chloride you have to react to get that much aluminum. So as always, let's start with the number given in the problem. Boom, that's easy. Oh, I love it when it's just an element. Here's another one. And we looked up aluminum, 27.0. Since the chemical formula for aluminum is simply 1Al, then that's equal to the formula mass too. So the first step is we're going to change from moles of aluminum to grams. I'm sorry, grams to moles. I'm getting so excited over these three-step problems. I can't talk straight. Okay, no problem so far. Next step, what do? That's right, mole ratio. We want aluminum chloride in the numerator and aluminum in the denominator. Well, we got to go look at the balanced equation here. Oh, right. It's a 1-to-1 mole ratio. Do you see that? 1 mole of aluminum chloride to every 1 mole of aluminum. Now, you're probably thinking, why do we have to write it in if it's 1-to-1? You're right. You technically don't have to write it in because it cancels itself out. I like to include it, and I want you to include it so that you don't get confused, because it does actually serve the function of changing the units from one substance to the other. All right, so, but it's a 1-to-1 mole ratio. We love it. 1 mole AlCl3 and every 1 mole of Al. Mole ratio done. And our third step, the second grams to moles, moles to grams conversion. Well, this time we do need to use the chemical formula of aluminum chloride, which, if you remember, we figured out before, 133.5. Okay, so that number goes on the top. That's the mass of 1 mole of AlCl3. And 1 mole AlCl3 goes on the bottom. And if we did it all right, ta-da! Grams of aluminum chloride. The only thing left to do is round to correct significant digits. Well, the original number, 650 with no decimal place, dose of those babies. So we need to have only 2 significant digits in the answer. All right, 3,200. Don't put decimals in there. Don't do it. Stop. Don't do it, because that will change the number of significant figures. The decimal place will automatically make those zeros significant, and we don't want that. We just want them to be placeholders. So there you have it. This is the final installment of the mole ratio problems. I would like you to try number 11 on your own. And if you're feeling really ambitious, go ahead and try number 12 and 13 and 14, where you're going to add the molecules in there too. That's the advanced step. All right, that's it. Please take a moment to click on the link for questions. I would like to hear from you with any questions you have. So click down there at the link that says enter your questions here and tell me what you're thinking.